video series, and I'm here with Saif at GDC covering what we're doing at the AMD booth for the Open Physics ecosystem. So Saif, can you introduce yourself and then tell us a little bit about the demos you'll be showing us?
My name is Saif Ali. I'm a software engineer for the Advanced Technology Initiatives in the office of the CTO. And today we're showing off ATI stream technology and specifically the physics demos that simulate various kind of natural phenomena, destruction and clock. And we're here at Game Developers Conference 2010, and we have 3 demos that we worked very hard on, and hopefully you will like them. So I'm going to start by showing the clock demo. That simulates clock in real time. It's written using DX11. Working exclusively on ATI Radeon cards, the 5870. So we have the samurai in the middle. The samurai is not cloth, it's an animated character, but all the banners and the curtains, as you will see them soon, they're all simulating cloth in real time. You can see that these curtains all simulate in real time, written, as I said, using DX11. I think it's quite pretty.
That's amazing. And do you have, can we see that wireframe mode? Wow.
That shows off the triangle count. The reason those curtains look so pretty is that we have very, very high polygon count. The detail is amazing. The city demo demonstrates, along with Pixelux, DMM, Bullet, and the Trinity engine, destruction. That is such, I guess, a desirable characteristic in games. You can blow up stuff in real time. So this is still a work in progress, but we can make this look really awesome. But this is what we've come up with for GDC. And so we have the mecha robot running around this little town, and then he can walk through stuff and destroy it. We have DMM objects embedded in this city, and all the DMM objects are the ones that are capable of being destroyed. So for example, this structure, construction structure here, you can walk right through it. And I particularly love destroying this one because you kind of systematically walk through all the supporting turrets and then it keels over on its side. It's very satisfying to watch. I guess hopefully I got it by that time. Ah, there it goes. There it goes. And then he kind of thinks about what to do next. Maybe he'll bump into this jello building, which I think is kind of fun. And then it kind of swings around. Oh, it keels over. The next one is a fluid simulation demo, and this simulates fluid as particles. And then this is written using OpenCL, the ATI OpenCL compiler, and then the rendering is done using DX10, DX10.1. And this we built from the ground up, from scratch, from absolutely nothing. So it's also a work in progress. Obviously we can make it look way more awesome, but this does 64,000 particles in real time on the ATI 5870, ATI Radeon 5870. And the rendering is pretty fast. As you can see, it goes in real time, over 30 frames per second. The main technique behind this is called SPH. That stands for Smooth Particle Hydrodynamics. Let's get a shot of it.
Are any of these demos available online, or is this just a...
So right now it's GDC only.
Okay.
I don't want to say anything about what the plans are, but with most of our demos, we aim to always get them online as soon as we can. Yeah.
Okay. Great. Okay, we're here with Chris from Studio GPU. Chris, why don't you introduce yourself and give us a walkthrough of your demo?
All right, so I'm here with Studio GPU. My name is Chris, and I'm here to demo our software, Mach Studio Pro. Mach Studio Pro is the real-time rendering and compositing engine that runs live off the graphics card. In this case, we're demoing with the ATI FirePro V8750, which is a 2 gig top-of-the-line workstation graphics card. And so this is Mach Studio Pro, and what we're showing here today is a small scene from a 75-minute movie that was brought out of Maya. The scene itself was modeled and animated in Maya and UV mapped in Maya, and we bring it into our software and do all the final lighting and texture work in our software, and we hit the magic button and we have a final rendering. Because we're running off the graphics card, everything is being rendered live on the fly. So we're not writing out any temporary files, we're not writing out any cache. Everything is coming straight off the graphics card, and only when we hit the render button in the end, where we render out final files, do we actually get to write out files to the hard drive. So what we're looking at now is actually a composited image of multiple passes that we see down here. All these passes are being rendered live by the graphics card and composited together. So what this allows me to do is that I'm actually seeing depth of field, diffuse, specular, shadows, transparencies, reflections, refractions, ambient occlusion. Everything is being rendered individually and composited together by our software. The other thing we're showing here is hardware tessellation and displacement mapping, which is actually a feature that is exclusive to ATI cards currently. If I switch back here, I'm going to focus on one of the objects here really quick and switch my camera here so we can kind of focus on what's going on. So I'm just going to come into this character here really quick, and if we look at this, what we're looking at now is the wireframe. This is the base mesh that came out of Maya. We have a volumetric light in the background, that's where all these white rays are coming from. But we have a built-in Cadmo-Clark sub-D system, so I can turn that on. That's where the basic subdivision is coming from. But what the ATI card allows us to do is that I can turn on hardware tessellation, and I can turn on my hardware tessellation on this, and I can just turn on the tessellation amount on the object. So what's actually happening now is that the wireframe is taking on the color of the texture that's on the wireframe at that point. So the wireframe is getting, the mesh is getting so dense right now that we're starting to see details in the texture map, despite the fact that we're still in wireframe mode. So we're getting sub-pixel tessellation, which means that we're getting single triangles that are smaller than a single pixel on screen. So we're still in wireframe mode here, and I'm probably running about 20 to 25 million polygons just on this one character currently. And this is all being generated live by the graphics card. So this is a little overkill. I'm going to dial this down. I'm probably running about 7-8 million polygons now. But what this allows me to do is, on top of normal maps that we support anyway, I can bring in a displacement map, which is a standard black and white displacement map that we created in Photoshop. And if I bring this in, I'm going to switch back out of wireframe mode. What this allows me to do now is create an actual physical geometry displacement based on a black and white map off the graphics card. So this alone, would take another couple of minutes or more than that out of any kind of software package. So this is just another pass for the graphics card, and because it's coming off the graphics card, I get a full rendering and lighting pass off of the displacement map. So with the full lighting pass, you can see I can still adjust this. I get a full ambient occlusion pass out of my displacement mapping here, so I can turn this up and down too with the ambient occlusion. So I'm just going to switch back here really quick, and you'll see here that I get a really nice displacement map off the whole character's head. That's definitely a 3D displacement. So if I switch back here to my full view, and I'm just going to bring back the other objects really quick. So we get we got all these passes with hardware tessellation and displacement mapping and depth of field straight off the graphics cards in a split second of any kind of software rendering that's currently out there. We've done some test renderings and come to the conclusion that in higher end settings we're rendering up to 500 times faster than current standard software packages. So currently with this information, we're probably in here in the viewport board, we're probably running at about 2 to 3 frames per second. With final output, with all of the settings turned up all the way for production quality, we'll probably be running, I would be guessing, no more than 5 seconds per frame for full HD and final quality. So that's kind of what we're looking at. And this is Mach Studio Pro.
Thanks so much, Chris. That was amazing. Really amazing.
Thank you. I'm glad you liked it.